Today on Xeno Diladon, what's more exciting than small generic laser beam steering galvanometers? Big name brand laser beam steering galvanometers. Here I have a Raylase TC-CS-14-C-Dig2 dual axis laser beam steering galvanometer assembly for beam steering the laser output from a large CO2 laser or YAG laser for things like engraving and marking and cutting on an industrial scale. And inside there are two Cambridge 6860 galvanometers and the amps, of which in this video I hope to get working. Alright, let's take a good look and see what we have here on the assembly. There are three boards on the inside. Looks like we have a controller, an interface right here. It looks to be a little chip. A couple of other things here for controlling the galvanometer signals. It probably does the signal conversion to the galvanometer amps. So this takes a digital signal, probably turns it into an analog signal, given the fact that these galvanometer amplifiers look to be completely analog in nature. We have a couple of wires going to the galvanometer amps. We have this wire right here, which is the signal input, probably the feedback for things like position detection and scan fail and stuff. So somewhere on this pin header should be the analog input for telling the amplifiers exactly the rotation of which the galvo should be in. We have this wire right here, which is by these capacitors, should be the input. So probably a split voltage or split power supply input like most galvanometer amps are. These are kind of like audio amplifiers, but a little more precise. Now we have the negative side of the cap, the positive side of the cap. Those should be tied to the COM. On the other side here we have the wires that go out to the actual galvanometers themselves. These two wires for driving the coil and for the position detect. Here are the two galvanometers here. This one has the rotation limiter on here, so it doesn't rotate all the way around, whereas this one is missing the rotation limiter on the front. And if they work, I'll just machine a new one. You can see this just goes all around in circles like that. It shouldn't do that, so that's a problem. So the first thing I'm going to do is I'm going to test out each galvanometer amp independently, see if the galvos find home. For doing that, I'm going to use this split power supply, which looks better than it, works better than it looks, and that'll give us our voltage, which will be about 20 volts. So go ahead and check that out. I'm going to be disconnecting the signal header, signal wire. It goes to the control board, just so we don't get any back feeding to the control board. And then I'm also going to verify the power inputs based on how the capacitors are configured. So, as I said, red should be positive, blue should be negative. We're going to use the multimeter for that. So, set the multimeter to continuity. Right here. Can you see that? Yes, you can. Alright, so the negative on this side and the positive on this side should be tied together, and then also tied with the black power common wire. Go ahead and test that out. Yep. And then with center. Yep. Alright, and then this side of the capacitor, which is positive, should be connected to the positive input of the galvo power. Yep, and this side, which is the negative side of the other capacitor, which should be connected to the negative input of the power for the galvanometer amp, which it is. Alright, cool. That looks good. So I'm going to put power into each amp independently, and I'm going to see if the galvos find their home position. So go ahead and try that. Okay, both signal wires are disconnected. Excellent. Let's try this amp first, which connects to the galvo that is missing the limiter in front. So let's see if that works. put that on backwards. Caps don't like that. Actually, let me verify the voltage is coming off there first before I plug it in. Oh, yellow is our COM on here, and our red should be positive, and our black should be negative. So, volts. Yellow COM, positive 20 volts, which we get, and negative 20 volts. Yep, okay, we're good. Unplug the power supply. And plug it in and we'll fire it up. Yep, alright. See if that galvo finds a home position here in the front. Now the power supply probably doesn't have enough current to drive the galvos at full speed, but for this application should be just fine. See, plugging it in. It did something. See if it's locked into position. Oh yeah, that's decently locked into position. Go ahead, unplug it again. See if it finds the same position. And I'm gonna move it a little bit and see if it homes. Yep. All right. Well, that galvo and amp look to be working pretty good. Let's go ahead and test the other galvanometer amp. Plug it. Unplug this side and see if the other galvo finds home position. Plug in. This one's going to be a little hard to see, so what I'm going to do is I'm going to put a little black mark on the shaft. Like that. And we'll see if that moves or doesn't. I don't see any movement. Let's rotate that a little bit. Is that locked? Oh, it is locked. So, yeah, it must be finding a home position. Just moves very little. Let's see. Got some lights here on the galvanometer amp. Let's see what it says. Unplug it for the time being. That way we can take a look at those indicators up close. That way you can see what they say. So, flip it around. Alright, we have positive and negative voltage indication and error. Well, the error LED is lighting up. That's strange. It should be finding the home position and ready. I think we have a mystery. Alright, let's go ahead and do some other tests here. Connect the galvo amplifier up to power again, and then what I'll do is I'll see what we're getting on the output. I'll go through and do a check for different voltages and see if we're getting any signal as far as like a scan fail signal. The scan fail signals are usually 5 volts, and we'll see if we get that on any of the pins here on this header. 5 volts is what we're going to be looking for. See if there's any indication of scan fail output, the error reporting feature on some galvanometer amplifiers. Nope. Oh, that looks like 5 volts. Alright, well, moving forward. Nope. Nope. Okay, so it's probably going to be some of these wires, which should give me rotation on the galvanometer. All I'm going to do is I'm going to use a diode check to inject power into the galvos and see if I can hear anything, although because it does seem to be having an error, I don't expect there to be much action on the galvos. I should be able to hear them too. Let's see. Oh, not that wire. These last three, let's see. That's probably going to be ground in the middle and then plus minus, so let's stick with this side, see if I hear anything. Nothing. Well, what happens if I jumper the output? Maybe that's some kind of an enable output. Let's see. Oh, it did something. Oh, it's tripping out my power supply. Well, that's not right. Alright, well, go ahead and see if we get any movement on the other galvanometer amp. See if it also shows error. Like that. Yep. And plug it in. Oh yeah, that red LED right there. So both of them are showing an error. That's interesting. See if we get any voltage on the test header, which is this header right here. Check for voltages. Nothing. Nothing. 4.2, that could also be a scan fail signal or an enable. Hold on. Negative 4.2. Negative 4.6. Don't know what that means. Interesting. Very, very interesting. Well, let's go ahead and see if we can put signal into these three right here and these last two right here. See if we get any movement. So, let's see. Nope. None that I see. That one goes to that galvo. Okay, well, we should easily see movement on that galvo. If I see movement on the galvo, you will be the second person to know. Nothing. Nothing at all. It might be looking for a signal from the control board, so let's take a look at the control board a little bit more. See what we can see. I'm going to be looking for a way to put power into the whole assembly, and I'll be looking for whatever possible enable signal we might be able to find. The other option, which was actually recommended, is to trace out where the error LED is going. Maybe that part needs to be bypassed. Let's take a look here. Alright, so see if there's anything that'll no. Hey, what is that? A V plus, V minus, and ground. Hey, okay, so I bet if I feed power, so V plus, the 2 right here, ground, and this V minus, those might be directly connected to the galvanometer amps and the supply voltage for the board. Let's go ahead and check that out. Again, doing a continuity test. No. Ground, COM. Yep, that's directly connected. Check out V plus and V minus. So V plus. Yep. And V minus. Okay. Yeah. So my thoughts are, I'll probably end up finding a wire that I could put in here to put power into. Now I don't know if there's any other power rails that may be needed, like a 5-volt power rail for driving the logic. There certainly seems to be. So this could get interesting. I see some inductors, and those inductors go to those 2 5-volt regulators there. I don't think so. Well, let me see what those are. Those are 5-volt regulators. At least I think they are. Alright, so what I'm going to do, I'm going to take a look at those parts, verify that those are 5-volt regulators, whether they're plus or minus 5-volt regulators, and then trace those back too. And probably I'll have to end up making my own pin header for multiple power supplies. The main power input for the galvanometer amplifiers on the pin header, and then the 5-volt power or grader that goes into these regulators and then drives the actual controller in the bottom. So that's the next step, and I'll get to it. Okay, now let's get this board prepped and wired up so we can feed power into it. There will be, I believe, 5 voltage rails that we'll have to supply to the 9-pin connector here. So let's take a look and see what we have. We have a V minus, which is the minus 20 volts I'll be feeding to the Galvo amplifiers. The 2 in the center, which should be tied in ground, and V plus, which is the plus 20 going to the Galvo amps. And we have the 5 connections down here, which go to a couple of linear voltage regulators. We have the 7805, which is a positive voltage regulator, and the 7905, which is a negative voltage regulator. Both of them put out 5 volts with their respective polarity. And on the other side here, we have another 7805, which will get a plus voltage. I have a split power supply, which is positive and minus 10 volts, which I'll be feeding to those voltage regulators. And we'll be working with feeding power from there. So the easiest thing, of course, is to start with the Galvo input, which is those 4 pins on the top. and I'll be using this little 9-pin connector to hook the wires up to it. Alright, so let's put wires on those 4. First, we're going to make sure that those 2 in the center are tied together. Yep. Alright. So that'll be this black wire here. Solder. And black wire. And then our positive and negative, which will be purple and red. So starting with the negative, which is on this side. And then positive. And then we'll trace out those voltage regulators. Okay, so on the LM7805, the pinout is input, ground, and output. Now with the negative voltage regulators, they're a little different. So we're going to start with the ground, input, and output. So this right here and this right here should be joined together, and it should be our ground. Let's test continuity between those. Oops, wrong ones. Yep, those are tied together. So now I'm going to look for the pin that's connected to the ground here. We'll connect the COM up to that. So let's see if we can find it. Megohms. Megohms. Okay, center pin is black. Are there any other ones? Nope. Alright, center pin is black. So let's get a negative wire on that. Or not negative. Common ground wire. Okay. On the positive input to the 27805s. So input, which should be the first one. Yep, so that's one. Now which pin is the other one? Nope. Nope. Okay, so it looks to be the first two. Are those first two pins tied together for positive? Yep, so one positive wire on those 2 pins. We're going to pull the connector off and just re-verify. That's what we get on the other side of the board. Yep. Alright, and then the negative input, which will be the tab of the L7905. So that one should be one of the N ones. Yep. And now let's check this one. Okay, that's those 2 it seems to be. Let's see if it's joined together here on these 2. Yep. Alright, and that's where our negative input's going to go. Well, that makes sense from an engineering standpoint. Alright, let's take a look at the solder job and see if we got any shorts. Looks okay. Alright, let's test the low side first. So, not the Galvo power, but the logic power. See how that works. There's a couple of LEDs on the back. Quite a bunch of them actually. And we should get activity on there if it works properly. And we'll get smoke if it doesn't work properly. So, moment of excitement. Here we go. So this is what I'm going to connect things up to. First our ground. Alright. Plug it in and check our voltages because there's a 5-volt output on that particular power supply, and that's what we want to plug into. So, power. I believe this is the 5-volt rail here. Yep. Which ones are negative and positive? That's got to be. Oh yeah, that's right. That's common ground. Okay, that's our positive, and that's our negative. Cool. Unplug the power supply for the time being, and wire up the rest of the inputs. And negative. That's a good thing to see a split power supply going to the control board. That's probably the negative and positive sides that go to the output for driving an analog signal. So that's another confirmation that those amps themselves are analog. So now that those are connected up, let's send power to the board. See if we get lights or smoke. I'm hoping for lights. You might not be. Hey, well, we do have some lights. good sign, I think. Okay, well, yeah. I think it's good time to connect up the galvos and the galvo power. So, unplug. Time to move the camera up. Okay, let's connect everything now. So, these are the galvo power wires. Go to the board. And we'll get the signal wires. Okay, those are properly set. Now, to the Galvo amps power supply here. So, V1, V2 ground, I see. So, negative side. Our COM wire. And they're positive. I'm going to do a final check on those connections going to the actual Galvo amps from the power supplies. Make sure that everything is on its correct rail. So, two Galvo positives should be tied together. Let's go ahead and double check that. And yep, we're good. Two negatives. Yep, we're good. Okay. COM to COM on power supply. We're good. Positive side of power supply. Good. And negative side of power supply. Yep, we're good. Okay. Next step is to make sure that there's no shorts. Nope. Yep, we're good. Okay. Everything's clear. Everything's good to turn on. Let's see if we get any errors on the Galvo amps. And if not, we're going to probe for a possible enable signal. So, here goes test number 2. Stop that. Something is not happy. But what and why? Different sound. Oh. Well, that's not promising at all, is it? Let's try to figure out why this isn't working. First thing that comes to my mind is, are the positive and negative rails actually supposed to be tied together from one power supply? To check that, let's go ahead and see if they're joined. Well, that's not a good sign. Positive join too? Oh, it is. Well, I'm sure it works better when I'm not trying to feed 20 volts into a 10 volt power supply. So, let's actually fully remove all the connections from this power supply and swap them over. I'll try to run everything off that 1 amp. Maybe we'll have better luck. Yeah. That does certainly explain a lot, though. Remove that completely. Alright. Now before I do that, let's go ahead and verify that on the board. See if they're tied together here. Yep. Alright. One power supply it shall be. I should put COM on this one. And positive. Okay, go ahead and see if the board powers up. Yeah. Plug it in, plug it in. Yep, board still powers up. We'll reconnect everything and see if the galvos behave as they should, or if we still get errors. Let's see. That one, choose that one. And that one, choose that one. Yep, looks good. Alright, let's see what we get. Power. Yo! Just behave. Okay, well, that's not working. Looks like we're going to have to see if there's any voltages coming from those pins alone. And maybe we can just feed those signals into one of the galvos separately. One of those could be an enable signal. So that's going to be the next thing to try. Alright, well, gotta go grab some paper. Okay, what I'm going to do now is try to figure out exactly what's coming out of this control board going to the galvos. Maybe an enable signal is coming out. So I am going to test these pins and look for a signal coming off them. There's a little test point right here, which is a ground. So before I check for voltages, I'm going to see what pins are ground. Oh, continuity. Nope. Okay, that's the ground. Let's see. Nope. Okay, that's also ground. And okay, that's ground. So another ground. Okay, next step is to check the voltages coming out of the other pins. So I'm going to power up the board. Let's see if I'm getting power. I am. All right. Pin number 1. Okay, so there's 5 volt right there. That could be our enable. Pin number 3. Oh, that's interesting. Another 5 volts. And the last pin. Negative 3 volts. Now that's strange. What are we getting on the other one? Negative 3 volts. Yeah. That's very strange. Oh. Huh? Yeah. I don't like that negative voltage being there. I have the feeling that that might be kicking the galvos off to a different position and drawing power. So I might try and run the unit without that negative 3 volts. We'll sit there, negative 3, B, question mark. Okay, well, I'm going to power up the galvos now alone and see what that 5 volts was coming off of. Move that off to the side. Move that. Okay, and plug in one of the galvos. You know what, let's plug in the other one. It'll be easier to read. Okay, galvo is on. Let's see what our pin out is. Okay, so that would go that way. So green, brown. Okay, I got it now. So let's see. Can't really read from the cable. Oh, that's not nice. Alright, so those are 2 ground ones. So 5 volts. Nothing. I want to plug in the galvo. Yeah. So we get nothing on where it was saying -3, which is what I would expect. Okay, so between these two, getting 0.3. That's a ground. Okay, so we're also getting +5 at the galvo here. So G and also +5 and no voltage here. Okay, and we're also not getting a voltage on the ground and the +5 volts here on that galvo side, so I'm betting that that's our enable signal. So possibly enable. So I'm thinking this might be signal, and that's scan fail output. Right, SF. And this might be signal. So let's go with that. I want to turn off the unit, and I'm going to try to inject 5 volts into the first 2 pins of the galvo, and let's see if that turns them on. Okay, at this point I have a good idea of what goes into the galvo signal cable. Let's take a look at this connector right here. Alright, I believe that it's a green enable, yellow ground. This one could be the error, ground, ground, and then signal. If we could narrow the 3 volts negative on there. So I'm going to do a couple of tests. The first test I'm going to do is I'm going to try to see if the white and the sleeved outer shielding is tied together and they're ground. So let's make sure that's how it is on the galvo amplifier. If it's open, that might be a close. Yep, those are open on the galvo amplifier. Let's see. Those are also open. Open. Okay, double checking. White and shield are closed. White and shield are closed. Okay. So let's go ahead, turn on the galvo amplifier and get some power going in there. So yes, we still have the error LED. And because they're jumpered together on the board, I'm going to also jumper the white and the black and see if that clears the error on the galvo amplifier. Nope, that error is still there. Alright, there is another ground connection, which is the yellow. I'm going to close that and see if that gets our galvo error to go away. Oh, that just makes it chirp. That's not right. Okay, well let's try feeding a positive signal in between the yellow and the green. To do that, I'm going to use a battery and a 1K resistor, so that way I don't burn out anything from the battery. And this should provide a pull-up signal if that's the enable. So resistor is positive. Wire sticking out on yellow is negative. See if our error goes away. And the error light is still there. And we're getting no rotation on the galvo shaft. So let's move over to the third pin and give that a positive input. See what that gets us. Oh, that makes it chirp. Alright, let's try these two grounds. And the error is still there. Okay. Let's try a positive reference from here. And the error light is still there. Very strange. Let's take see if we can still locate that positive reference. It might be the scan fail out. So back into volts. Ground should be nothing. And this should be 5 volts. Nothing. This is our 5 volts out. Okay, that is our 5 volts out. No error clearing at all. Try giving it a negative signal off the ground. And maybe we'll hear some deflection. So that'll be a negative reference. So positive on the ground, negative input. No change. If we close this, what do we get? Nothing. Huh. I'm good and stumped right now. Well, I think it's time to go to my happy place. And little creatures that live in the magical forest say that my happy place is right in here. So let's take one of those apart. This week on Galvo vs. Guy, we have the Cambridge 6860 galvanometer, capable of doing several tens of thousands of points per second, versus Xenodilodon, capable of doing several sets of 10 per second. Alright, let's get into it. I'm going to start with the front piece and the roll pin. Get those loose. Yep. So right now I'm taking off the rotation limiter on the front, which is the piece that's missing on the other galvo. Let's take a look at that. Oh yeah, that's pretty simple. So the pin sits in there. There we go. So that pin here, that roll pin, sits inside that, and that limits the travel the galvo has. Let's move on by taking out the roll pin right here in the front. piece of metal that protects the bearing in the front. And that holds that up off the bearing. Another little bearing cover. Now there's another little bearing spring, like friction leaf spring in there. Alright, 3 screws on the back. Now this is all one piece here, so when those screws are undone, this should slide off like that. We can see what they use for the feedback on the inside of the galvanometer. That should be the smaller one. And I'm going to do this very carefully. I'm going to hold the assembly together. Alright. I don't want to take the chance of clipping any of those little copper wires that go up to the galvanometer coil. Now, before I undo that, I'm going to mark what the rotation is on that versus the case. Alright. Now I expect there to be the electromagnetic coils on the inside, so I want to open this up as carefully as possible to avoid tearing those. Oh, I see that back plate does come off. Okay. Yeah. So what do they use for the feedback? Can't really tell right now. It looks like it's going to be on that board. And we have our 2 electromagnetic coil feed wires going up to the galvo coils, and those are in the center. See a pair of screws, so I'm going to remove those and remove the coil wires. Soldering iron. Once those are removed, everything else should pull up rather easily. Oh, that's not pretty. Got to get that silicone glue off. Alright, I need something to pick at that a little bit. Stupid screwdriver design. Okay. Oh, that is one of the coils. Alright, well, let's take that one out anyway. Alright, now I need to re-wet this heavy iron. Well, maybe it's soldered in from the other side. Probably is. Go ahead and remove those wires. Not the wires, the board. I do envy your view right now. Okay, this is going to be a mix of metric and standard, because right now I'm having a heck of a time. Alright. Oh, there's another layer in there. Holy heck. Ah, those are the galvo wires. I see, I see. Wow. I have a feeling that's all. Yeah, with that transformer there, that's got to be capacitive. Wait, I brushed off my original. Oh, nope. We're good. Cool. Alright. Wow. Let's disconnect some wires. White. Black. Yeah, I can remember that. And then this red wire up here. And then that center wire. Nope. And the galvo wires. Man, this is a tight little unit. That's for sure. Alright, that's yeah, I've never taken apart one of these Cambridge technology galvos before. That might be obvious to some of you. Alright, so a couple of wires. We have the galvanometer coil wires right here. We have this wire and this wire here. And we have a little chip there. I'm not sure what that chip is at all. So this looks to be capacitive feedback. So underneath this plate we should see our capacitor plates. You can take a good look at those. And that probably is some sort of comparator up on the top. So take a look at that. So if it is a capacitive one, which I think it is, what it does is it'll generate a signal, and it'll measure the capacitance of a fin, and that fin will change the value of the plates. It's kind of like an air gap capacitor. Actually, that's exactly what it is. Oh, you're also connected to that. That doesn't matter if we can show you what's happening on the inside here. So here we have what I was talking about. So we have one of the plates for the capacitor here. So this would be our dielectric, and when the galvo shaft rotates like this, it moves back and forth on that plate right there. On the other side, we'll have two joined capacitor plates here. So we're going to see that this one and this one should be joined, I think. Yeah, this one and this one and this one and this one. So it'll measure the capacitance that is between that plate here and we'll treat these as capacitors. So it's two capacitors that share a COM. That would be the common plate, and on one side you have these two, and on one side you have these two, and depending on the capacitance between the plates, this will know exactly where it is as far as the position detection goes. Now, underneath here is probably going to be where the galvo coil and magnetic assembly is. So inside of here there's going to be a diametric magnet. And I don't want to mess around with the tuning of the capacitor all too much, but it looks like that that would probably need to be removed in order to get to the coil assembly. Let me push up on the front and see if it slips out. I don't have to mess with the tuning. Be very careful with this. Oh yeah, it's not budging, and I don't want to push it out and break anything. So yeah, but almost certainly on the inside you have two electromagnetic coils, and they're looped. One would be looped, and the other one would be looped. You have a diametric magnet on the inside. That means one side of the magnet would be north and one side would be south, and it would fight between those two poles, and that's how it rotates back and forth. Oh yeah, pretty neat assembly. Well, alright, well, I guess that's as far as I'm going with this, but you saw the important bits. I'm going to get this put back together. Let's take a closer look at the feedback system a little bit. So I think we have an oscillating circuit on here. So that would be either a transformer or inductor. We have a pair of transistors, a couple of capacitors here. And how I think this works is it'll send a sinusoidal wave to the capacitor plates on one side. And when the dielectric is moved, it'll either change the frequency of the circuit or the amount of electricity leaving the circuit. And it compares those signals and determines where the feedback position is based on that. So the top board is the oscillator and frequency generator. You have this board right here, which is that board with the two other capacitor plates, and here, which is the common of those capacitor plates with the dielectric in between. And that's how it all works. Now, before I go into the next part and lose a whole bunch of people, I just want to go over the level of complexity of this galvanometer amplifier versus what I am used to from a show laser. So let's take a look at one of those show laser galvanometer boards. It's fairly similar in construction. We've got these pins right here, which are the ground and then the positive and minus power inputs for the galvanometer amplifier, along with the two filtering capacitors that clean up that voltage a little bit. Got this IC right here, which is an amplifier IC, and it takes the lower level signals and amplifies those up to a higher voltage and current, which drives the galvanometer coil, much like it would a speaker. There's these two ICs right here, which are just linear voltage regulators. I think they're 15 volts. One is positive and one is negative. Got the galvanometer output right here, and we got the signal input right here. We have these potentiometers right there, and these are used for tuning the galvanometers. And there's your output for the scan fail, and a couple of ICs right here. So an IC here, an IC here, and another IC here. Well, it's these two. And most of that is operational amplifiers. These are two single operational amplifiers, and these are quad operational amplifiers, along with a couple of diodes, transistors, resistors, capacitors, and other passive components. Now let's take a look at this galvanometer amplifier. A couple of things to note. We got two types of ICs to really pay attention to. Got these two right here, which are LM339s, and we have the other ICs right here in the same package, and those are all quad operational amplifiers. Well, not this one. Now let's take a look at a comparison between both the boards. So that's how that side looks. This is that side. I don't have to worry about these two all too much. They're in parallel, so they're doing the exact same thing, and are just tied together for a higher current function. But take a look at the other side, and the level of complexity is quite different. Now, I've spent a couple of hours in trying to trace out everything on this board. We got a little bit more of an idea of what's going on. And here's that. Now this is where it gets confusing, and where I probably have forgotten a bunch of this schematic as I was doing it. But let's start off. I have the two positive and negative voltage regulators here. So that one and that one, and these provide 12 volts, positive and negative to this the board. And then we have the two LM339s, which are their comparators. So you have two chips to really pay attention to: comparators and op amps. Now they do kind of the same thing, except that comparator is a lot more like a switch. Whereas if V1 is higher than V2, you'll have an output signal that's high, and if V2 is higher than V1, it'll tend to pull down to ground or to the negative of the chip. Whereas op amps are a little bit more linear. They scale kind of like a transistor does, or a potentiometer, where if V1 is slightly higher than V2, it might not go all the way up to the input of the chip. You can balance it out. As I said, it acts a little bit more like a classical linear transistor instead of kind of like a switch. It's a little less absolute, has a little bit more range of gain. It's not so sensitive. Well, yeah, the one thing you have to kind of keep in mind is these are quad packages. So in both the quad operational amplifiers and the quad comparators, they have 4 separate amplifier circuits or comparator circuits inside. And just because the chip has 4 of them inside does not mean the components, the amplifier comparators in the chips are doing the same thing or tied to the same circuit. So you can kind of trade each one of the 3 connections at the end. It's like the amplifiers, and it won't matter. As long as all the voltages are the same going to all the chips, you can kind of play around with them and trade them. So you can have one chip that's tied to one portion of a circuit, and then another part of that same chip is completely independently tied to another portion of the same circuit. So the portions that I tried to look at the most were for the error reporting, trying to figure out why I'm getting that error. Let's take a look and see what I figured out a little bit. Let's start off with the error LED itself, which on one side it looks to be pulled to the negative, the ground. So it's pulled to the ground, and that would be this transistor right here. So that transistor is tied into the resistor, which is tied into the error LED, and the other side of the error LED is on ground. So I'm thinking that's an NPN transistor, and the transistor is then turned on through another 10K resistor here on this LM339 or 399. Let's take a look again. Got the numbers correct. It's LM399. All right. I've seen a lot of LM393s, but we're not going to talk about those. All right, so follow that back. It's going to be the 2 pins next to that are going to look for a voltage balance on V1 and V2, the input of the comparator. Now a lot of that is tied into this IC right here and this transistor right here. So this IC, can't really figure out what exactly it's doing. Tried to look up the data sheet for it, and one data sheet says, oh yeah, I'm a gate driver IC. Well, it's not a gate driver IC. It's not tied to the main output of the amplifier, or the input of the amplifier IC, so I don't see it driving that gate. The second thing that I've noticed is that, or the second thing that I saw was that it could be a drive IC for like a switch mode, PWM kind of thing. I don't think that's it either. It could be generating some kind of signal for, say, comparing against the oscillator inside the galvos. Once again, can't find the data sheet that exactly explains this IC and goes along with what I'm drawing out as far as pinout diagram. It is tied to the 12 volt reference here, and I do believe that there is a tying to the 12 volt that comes directly from the output of the capacitors. So it possibly has a way to measure against a 12 volt reference whether the voltage coming in to the main power pins of the galvanometer amplifier is at the correct voltage. Now this thing is supposed to run on 18 volts, I believe, and I'm feeding it a little over 21 volts. So there's quite a difference, which could easily toggle an error in the system and say, hey, no, look, we have too much voltage, cannot run at this voltage properly, there's a problem, and it cuts off the signal. It is also tied into the mute, so there's another transistor, yeah, this bugger right here, which ties into the mute and out of the output of that LM339 as well. I've also traced out this pin, which I believe is the enable, the first pin over, and that does go up and around and to this transistor, which looks to be another NPN, which just pulls down one of the inputs to the same rail that the error reporting goes to on the LM339. So yeah, this is nowhere near done, and it could just be a case that I'm feeding it too much voltage. Now that does bring me to a little bit of an impasse, because I do have 18 volt power supplies, but they have nowhere near the output current that this galvanometer amplifier requires. If they're doubling up two of these ICs, and they're 96 watt ICs, they could be taking in 2 to 3 amps a piece, and my power supply only puts out 1 amp on one rail and 0.8 amps on the other. Just not enough current to drive it. So not even concerned with trying to use those. The other side of my impasse is that the power supply that I have been using to test this only goes down to 21.5 volts. It won't drop any further. I tried to bring down the voltage. It's just there. Some modification would have to be made to get that power supply lower. So I'm kind of in a position where I can't test the hypothesis of the voltage not being correct. It is how it is, but that's my suspicion. So yeah, I do believe this is enable. These are verified to be grounded on the controller that the amplifier gets its signal from. And what's interesting is that when this is all grounded, it looks to go into a state where it just clicks, 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 clicks. That's a little confusing. Otherwise, yeah, 5 volts out here, I think is my error reporting. And I really do think that either this pin alone is responsible for the position signal that goes into the galvanometer amplifier. But it is very complicated. This whole thing, it helps. It gets an idea of what's going on. That could be a simple problem of, hey, there's too much voltage. So I don't know what to do at this moment. I may do a simple wrap-up of the whole assembly. I may figure out something and get this thing to work. But right now, I'm kind of stumped. So, alright, at this point, I think I'm going to have to wrap up the video. Sadly, I still can't get this to work the way I want it to, and I have a couple of thoughts. Now, I've done a couple of things. I've tested the semiconductors, so the comparators, the op amps, diodes, transistors, things like that, the resistors, and the majority of the capacitors. The voltage is going to the comparators. They correspond, so their input and their output is what it should be, from what I can tell. I do think that it's a power supply problem. Now, these are split rail power supplies that have a positive and negative output, so finding larger power supplies that are tunable for this particular circumstance can be rather difficult. I don't have access to one that'll do 18 volts with higher than, say, 2 amps, and this unit probably takes more than 2 amps, and I do believe that it's 18 volts. It's just what my brain and what the information on the internet points me to. So the galvos might be tripping because A, there's either too much voltage and it's telling the galvo amplifier not to operate with that higher voltage, or B, with the connections grounded on the signal in the same way they're connected on the controller board, or when the controller board starts up and tries to go through kind of a calibration sequence, there's not enough current for the galvos to do their job, so they're tripping out my power supply. Yeah, at this point I don't know what else to say other than stay tuned for more.